greatest common factor. Alright, this one, I'm going to teach you what it is and show you how to find it. Alright, here we go. Alright, so watch the factor tree video before you watch this one. Very helpful if you already know how to do factor trees. Should be fine. Okay, so what is a factor? Just a refresher. It's when two things multiply together to get another number. So in the case of 2 times 3 equals 6, 2 and 3 are factors, 6 is called the product, but we're just interested in the 2 times 3, and we're only interested when they're whole number integers, meaning there's no decimals, no fractions. So if we have two numbers, we want to ask the question, what is their greatest factor they have in common? Well, first we need to know what their factors are. So what numbers multiply together to get 6 and 12? So let's start by making lists. So I like to start with 1 and count my way up. So 1, does anything times 1 gives us 6? Yes, 1 times 6. Does 2 times anything give us 6? Yes, 2 times 3. Does 3, do we need to keep going? Well, once we see that once we get to a number we already have on the other side, we're fine. So next number would be 3, but because we already have 3 on this side, we know that 3 times 2 gives us 2. And we know that there's nothing times 4 can give us 6, because that number we would have seen already in 5. So these are the 4 factors of 6. What about 12? Well, start with 1. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. 4, we got the 4, we reached the other side, we're fine. So we know we've gotten all our factors of 12. So just by looking here, let's start with which factors do they have in common? They both have a 1, they both have a 2 because they're both even, they both have a 3, and they both have a 6. So they're pretty related. Now the question is, what is their greatest factor they have in common? Well, of course that would be 6. And if you notice, the greatest common factor can be the number itself. So in this case, our greatest common factor, you'll sometimes see it, well, mostly you'll see it as GCF, is 6. Let's take a look at another. Let's take a look at some bigger numbers. Let's take a look at 36 and 45. Great. All right. Let's list our factors. 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5, no, 6, yeah, 6 times 6, and we don't need to go to 7 because we've already we have the same number on this side, so we know that we've just completed the loop. Okay, so we know we've got everything. 1 times 45, oops, not 2 because it's not even. 3 times 15, yep. 4, no, because it's not even. 5 times 9, 6, no, because it's not even. 7, no. 8, no, because it's not even, and we got back to 9, we completed the loop. So start with which factors do they have in common? They got a 1, a 3, and a 9, and now the question is what's their greatest they have in common? It's a 9. Now, there's a couple problems with how we do this. One, if our numbers are big enough, we're going to end up with we're going to have to list out a bunch of things. And the second problem is, what if we miss one by accident? What if we completely missed our 3 times 12? Well, there's no way of knowing exactly unless you just know your numbers that well. So let's look at the method that'll guarantee we always get our greatest common factor. So let's use our factor trees. So let's start with, do it exactly how we did it in the factor tree video. Let's start by making our branches, and remember they could be any two of our numbers. So 36, let's just do 6 times 6. 6 can be broken down into 2 times 3. Those are both prime, so we're done. 6 can be broken down into 2 times 3. Those are both prime, so we're done. So 36 is the same as 2 times 2 times 3 times 3. And then 45, let's do 5 times 9. 5 is prime, so we'll circle that. 9 is 3 times 3. So what do we got? We got 3 times 3 times 5. So we want to know what factors they have in common, the way we have them written here. They have 2 3s in common. So let's take those 2 3s. And what's 3 times 3? 9. That's exactly what we got for our greatest common factor. Let's try another. Let's try with our 12 and our 6 again. 6 can be broken down into 2 and 3. 12 can be broken down into 2 times, that's not right, 2 times 6. 6 can be broken down into 2 times 3. We're left with 2 times 3 over here. We're left with 2 times 2 times 3 over here. What factors do they have in common? They both have 1, 2. They both have 1, 3. 2 times 3 is 6. Bam! That's exactly what we got for our 6 times 2. So, to get our greatest common factor, we can use our factor tree and guarantee that we get the right one every time. Let's take a look at the application of greatest common factor. So whenever we have fractions, we want to reduce them so that it's in lowest terms. So what that means is if we have like 2 over 4, we want to reduce that to 1/2. And the same is for all fractions. We want to be able to reduce them in lowest terms. And the way we do that is actually using our greatest common factor, because if we can divide it into both of them, they'll cancel out. Just like our 2 and our 4, they're both even, so we divide by 2. 2 divided by 2 gives us the 1 in the numerator. 4 divided by 2 gives us the 2 in the denominator. I don't know why I explained it instead of just writing it. Should have wrote it. It's okay. Y'all are good with that. So let's see in this case. These are two huge numbers. We're not going to know their factors off the top of our head. And if we tried to do it one by one, we might be here a while. So let's use our factor trees, see what we can do. So let's start with, what can we break this down into? Well, that 0 should tip you off that we can multiply by a 10. 10 times 1, 68. 10 is the same as 2 times 5. 2 and 5 are both prime. We're done over there. 168, you may not know, but we know that it's even, and I'll go ahead and give you a step more. It's actually divisible by 4 too. But if you just saw the even, you could do the 2 and it would work just the same. 4 times what? 42. 4 breaks down into 2 and 2. 42 breaks down into 6 times 7. 6 times 7. And then 7's prime. 6 breaks down into 2 times 3. So what do we got? We got 2 times 2 times 2 times 2 times 3 times 5 times 7. Boop, boop, boop. All right, let's take a look at 2,700. Those two zeros tell us we're multiplying by 100. 27 times 100, that's pretty nice. 100 is the same as 10 times 10. 10 breaks down into 2 and 5, 2 and 5. Those are both prime, so we're done with these branches. 27 is the same as 3 times 9, and then 9 is the same as 3 times 3. All right, let's rewrite these factors. 2 times 2 times 3 times 3 times 3 times 5 times 5. All right, so let's take a look at what they have in common. So they both have a 2. They both have another 2. They both have a 3. And they both have a 5. That's what they have in common. Now, you may say, so what's 2 times 2 times 3 times 5? Let's start with 2 times 5, which is 10, times 2 is 20, times 3 is 60. So 60. 60 is the greatest common factor. And you might say, great, now I got to divide both of them by 60. We don't, actually, and here's why. Because whatever's left over, because this whole line is multiplication, if we're dividing by 60, we're just dividing by the factors of 60. So all we have left are our 2, and our 7. What's 2 times 2 times 7? 4 times 7 is 28. And then what do we got over here? All we're left with is our 3, and our 5. 3 times 3 is 9, times 5 is 45. And so this reduces to this because we knew the greatest common factor was 60. And now that we have 28 over 45, we can be sure that it can't simplify anymore because we see that they don't have anything left in common. So that might be an abstract application, but the more tools you have, mathematical tools you have in your belt, the more often you'll be able to use it. You can't use it if you don't have it, but if you have it, you're able to use it. So I hope you find those opportunities. I'll see you in the next video. Bye.